talk about tools. I want to talk about a couple different things. Tools, for one thing. Simple things like screwdrivers. I've been looking for a ratcheting screwdriver, and this one was highly recommended. This client, it's called Clink Select-A-Bit. It has the bits in here, and it goes like that. Made in the United States, really, which is kind of nice. The only problem is it's loud, and it's kind of clunky, and you can't get into spaces. So I was kind of frustrated with that tool. So I found this one. This is a Canadian one, and this one is absolutely silent. And it ratchets, so there, and you can turn the ratchet and go like that. Holds all the bits in the handle, so you've got all of your standard stuff and your weird stuff all in one unit. About $25 on Amazon. This one, highly recommended. This one, it's fine. This has this big gear here because it has a 1-to-4 ratio, so you can quickly undo screws, which is handy if you're a mechanic. But for the electronic stuff, this sort of thing I find is far better. And then there are little things in tools like, these little sets of hex keys and all these strange bits that you need for all the electronics. This Titan brand, another Amazon find. Here's some example of some good designs. Different colors for different things. The red one is this, and this is metric, and this is Torx. And on the side it has laser etched the sizes of everything, so you know what sizes are in there. So just little things like that can make it real handy as you're building up your toolbox of stuff. The other projects we're working on, I talked about the mesh stuff a little bit already. That's been kind of on hold. One interesting project that I've been working on is this is a newer product from Microsoft. It's called their adaptive controller. It's actually an Xbox game controller, but it is designed for folks with disabilities. So instead of a regular handheld controller, see all these little holes in the back? You can connect your own devices to these. Okay. So you can connect your own buttons and everything. So it was designed for people like in a wheelchair, or, if you have one arm, how do you use an Xbox controller? Or a PlayStation or whatever else. So, and one of the things, the problem is it uses the joysticks. So the joysticks are very expensive. So I developed a 3D printed joystick for testing that these plug into the side for testing purposes. So the case is 3D printed and it's a little stick, but I could use this idea to size it to somebody's particular needs. So if somebody had a particular, like some of the wheelchair-bound people uses the blowpipe, things like that, or can only move their head, stuff like that.
Or maybe you need a thumb switch that goes this way and not that way because they can move their thumb in one direction.
Correct. And what's actually inside here, there is an Arduino inside here, which simulates a USB controller. So you could plug this into a computer, it'll show up like a regular joystick. So really neat technology that Microsoft has come out with this. If you know anybody who has disabilities, it's worth looking into.
Can it be used with other devices besides the Xbox?
It'd be used with any computers. Yep. So, and it could be used as it shows up as a controller on the computer. So you could use it to control mouse movements or other movements on the screen if you needed to.
Me and my wife were into occupational therapy, and we work with many individuals who have many different types of disabilities, and might want to.
Sure. Yeah, we need to hook up on that because that's one of my big interests is. Okay, who knows the Morse code?
I That's an ID,
Yeah, I was doing its hourly,
identification.
it's a repeater. What's cool about this is you could do that sort of custom joysticks if you know electronics, but this just takes regular kind of headphone jack wires, so it doesn't require soldering or anything else. You can take a look at it. But yeah, we could talk more about that offline.
It's a giant breadboard?
Almost, yeah, if you think about it. And those two big black things those are just push buttons.
Just a big guy.
Giant, mashy push buttons.
Yeah, I've seen this on the television, on that commercial about it. Mm-hmm. And, you know, I was very impressed and happy that they were coming out with something like this.
And what was really impressed me when I received that was the packaging it came in.
Oh, yeah, the packaging.
Because it was designed for somebody with very limited mobility. Like instead of regular packing tape, there was a special hole in a hook where you could pull with one finger and open up the tape. Everything had flaps that you could open it, so somebody who just...
Somebody was thinking about it.
Right, they spent a lot of time on that. And on the bottom of it, it's got mounts for wheelchairs. Really neat stuff. So what needs to happen with that device is it needs more hackers to bring lower cost things like these joysticks to it. But yeah, we could certainly talk more about that.
Thank you.
The other big ongoing project, which has been going on for years, which we're kind of on version 2 of, is our Microscope project. This is a Microscope automation project where the stage of the scope, and this is the stage, the X and the Y, which I'll move by hand. We want to drive it with these stepper motors so that we can have a computer or a microcontroller control it. The earlier version had belts and everything, and now I've got direct drive gears. This is an Arduino Mega microcontroller to operate it. It can be manually moved around with the joystick, and you hook camera through the eyepiece like that. And there's other sensors I'm working on here. This is an RGB sensor. This senses color, so if you could look at that screen there, you could see it. If I didn't reset it, it picks up different colors. Been working on this project most recently with a veterinarian in Croatia who he works with a university. He's a professor at a university, and they are trying to detect cancers in dogs. And the problem is with veterinary medicine is they don't have the money that human medicine has, so they have to take existing things like a regular microscope and add onto it. Cameras and stage automation and everything is available commercially, but it's very, very expensive. So your vet couldn't afford it. But with this, the idea is that the computer would take a slide, take picture, save it, and then it would run it through an artificial intelligence program, which would then determine if there is a cancer without any human interaction at all, which is kind of cool. And the resolution is pretty good. I'm going to end with this. Right in the middle of this calibration slide, there's a tiny little spot in the middle. If you can see, I don't know if you can see it. Take a look at it. Try not to mess up that slide. The circle is an outline of where it is. That's not actually the thing. The little thing is in there. It's at the 10 micron level.
Can't see it.
It's 1/100th of a meter, and the divisions are in 1,000th of a meter. But I'm able to blow it up to that. So this super teeny tiny, this is bringing it up to about 1,000 power. Non-oil, it's air. So that
And
is.
what camera does that?
This was out of one of these, one of these video cameras.
From where?
Just an Amazon webcam. Yeah.
It's using the microscope's lenses.
So what I've done is I 3D printed, this is where the 3D printing comes in, the 3D printed the adapter, which then hooks onto here because,
What I was getting at is, usually you need it, for 1,000 power, you need oil immersion.
yes.
So you said you can get 1,000 here without oil?
Yeah,
you think?
there's aberration and everything. I wouldn't normally do it, this was a test run. Normally, it does have an oil lens right there on that one. What happens is the higher the magnification,
So
the
what-
more distortion you get.
Objective are you using, 800 or what?
I'll use like a 40 on the bottom and then 25 up top.
Okay, so it's 40, 25.
Yeah. Or whatever I've got, yeah. But, yeah, another person I'm working with, a grad student in Michigan, is working on a similar project, except they're using a Blu-ray player to take images. And we have gotten successful scans of a dime. So what we do is we take all these individual pictures of a dime and we slice them, put them all together. It takes 7,000 images to make one dime. So that gives you an idea how high resolution this is. 7,000 pictures to make something the size of a dime. So that and those scopes go beyond what optical is. This optical could do about 1,000 power. But we're working on the nano side of things with that. So we're actually able to see virus-sized things with a piece of equipment that costs under $100, which is that's the cool part. This stuff exists, but it's super expensive. And the whole point is to, like, all of this, even with the camera, is, well, except the scope, is under $100. So, making it feasible. That's it for me. Evelyn, I want you to finish off with your butterfly. We're